This presentation is about Raney Nickel. Raney Nickel is a heterogeneous catalyst first developed in 1924 by an American engineer, Mary Raney. Now, Raney is a W.R. Grace and Company registered trademark, and so products that are essentially Raney because of their similar physical and chemical properties but made outside this company have generic terms like skeletal catalyst or sponge metal catalyst, as we can see why. Macroscopically, every particle produced has a three-dimensional mesh containing irregular pores. This catalyst is composed of fine grains of mostly nickel derived from a nickel aluminum alloy via a leaching process using a base or an acid. Using sodium hydroxide, most of the aluminum in the nickel aluminum alloy is extracted to form the sodium aluminate, leaving nickel to absorb the hydrogen produced, which Raney describes as a hydride. Today, this nickel hydride is the most used catalyst in hydrogenation reactions. An example of the proposed mechanism for Raney nickel is in the hydrogenation of alkenes. Here is the metal produced in the reaction. The hydrogen produced in the reaction in its diatomic form gets deposited on the surface of the nickel catalyst. Once adsorbed, it dissociates into hydrogen atoms. The alkene will then adsorb to the nickel catalyst. One of the hydrogen atoms will transfer from the Raney nickel to one of the alkene's carbon atoms. This will form a partially reduced intermediate with a carbon-hydrogen bond and a carbon-nickel sigma bond. Another hydrogen will bond to the other end of the double bond. This causes the pi bond to break to create bonds with the hydrogen, resulting in an alkene. The nickel coordinates the hydrogens to be on the same side of the double bond, resulting in a product with syn addition. The alkene has only a small attraction to the nickel, so it is desorbed from the surface, leaving a vacant space for the adsorption of a new alkane and hydrogen molecules, and the process continues. Because of its ferromagnetic property, Raney nickel can be easily separated by magnetic force. Because of its excellent catalytic activity and its ability to store the hydrogen generated during activation process in its pores, Raney nickel is an ideal candidate for the catalytic conversion of biomass. Lignocellulose is the most abundant type of biomass and has three main components. One of the many products of lignocellulose is glucose. The hydrogenation of glucose goes through the proposed mechanism since carbonyl is also an acceptor. The hydrogenation of glucose to sorbitol has a significant role in the industry in the valuable application of sorbitol as an additive in foods, pharmaceuticals, and cosmetics.